Good morning, teacher.
Good morning, Anita.
Sorry, teacher, that I am late, but I forgot that we have math. Sorry.
Okay, Anita. So here, guys, we were solving these questions, and we solved till the third one, I think, if you remember.
No, I solved all of them at home.
Okay. So if you want, I can show also fourth one, or I can start with the circles directly, how you want. Did you check them at home or not, others? Did you check the questions or not?
I didn't.
You did.
I didn't, teacher. I didn't have time.
Okay. So here, guys, as you see in the figure, ABCD is a trapezoid with AB is given as A. This part is A. And DC, the upper base, is C. And A is equal to 5C. Find area or the ratio of area of DEC, the triangle DEC, and the area of the trapezoid ABCD. I will write the area of the triangle here. Look, if this one is 90 degrees, also this one is 90 degrees. And this triangle is a right triangle, yes? And one of the side we know. If I will say that DE is H, because it's H of the trapezoid, how will be the area written here?
It will be AB times H over 2. Like AB is side, whole side.
AB times H over for the area of triangle. Yes, I'm talking about the triangle.
D times H over 2.
C times
C
H,
over
yes.
2.
C times H over 2 will be the area of the triangle. What is the area of the trapezoid? It is A plus C.
It will be
H over
C plus 5C
yes.
times H over 2.
So because A is 5C, 5C plus C times H over 2. Now, as you see here, we have fraction, but a mixed fraction, like both of them in the numerator and denominator, we have different fractions. Because here in both of them is 2, I can cancel these 2's, okay? And what we'll have C times H over 6C times H. And because you have multiplication between them, H will go, C will go, only 1 over will be the result. So the area, the ratio of area of triangle to the trapezoid is 1 over 2. Okay?
So teacher, we should find the ratio.
Yeah, find, look here, this one.
Okay.
It doesn't want to find the separately the areas, only the ratio. It's okay, guys?
It's okay.
In the other one,
Yes, teacher, it's okay.
area is given, area of the trapezoid is given, upper base is given, the height is given. You will find the lower base, and then with the Pythagorean theorem, you can find this x here. It's not that hard, only you have a bit more work. Now, today, we'll start with the circles, guys, finally. If you have your book with you, you can take your book, not to write them, not to take time, because these are like all definitions and you have them in your book. You can follow from the book, okay? It starts from page 144. And here we have some basic concepts. So firstly, definition of a circle. A circle is the set of all the points in a plane that are at the same distance from a fixed point in the plane. So there is a fixed point and there is a distance from that point to the points, all the points around it. So we call it circle. And this distance is called the radius of the circle. The plural form is radii. And the fixed point is called the center. So as you see here, we know them. O is the center point, the fixed point that is not changing, and the distance from the center to the circle is called radius. Now here is, as you can see, we have some regions of the circle, interior region inside the circle, the region inside the circle, and exterior region out of the circle, and the circle itself. Okay, there are three different regions: interior one, exterior one, and the circle itself. For example, here the point R is in the interior region, point Q is exterior region, and point P is on the circle. Okay, did you understand? There are three different regions: interior, exterior, circle itself. So here, for example, if I will ask you in this example, which points are in exterior region?
G,
E, F.
F, and E.
G, E, and F, they are in exterior region. Which points are on the circle?
D,
A, O, B.
On the circle,
D
B
and
and
C.
C.
D and C, they are on the circle. And interior region,
B, O,
A, B, O.
B, O, A, they are in the interior region. So we have, if in the question it says that point D is on the circle, you need to draw on the circle, on the line, okay? You need to put a point on the line.
Okay.
If it says that point, let's say C is out of the circle or in the exterior region, you will put the point out of the circle. If it says in the interior region, you will put inside of the circle. Now, auxiliary elements of a circle, and there is another definition here. A line segment which joins two different points on a circle is called a chord. So look, the points are on a circle. So the points are on the line, and a line joins them. Look, A and B, they are on the circle, and when we join them, it's called the chord, okay? This is called chord. A chord which passes through the center of a circle is called a diameter. So look, you have the points C and D, and when you will join them, the chord will pass from the center O. So this one is called a diameter. I think that it's the same in your native language, diameter. Yes?
Yes, it's diameter, yes.
Yeah. So did we understand the chord and the diameter?
Yes.
Yes, teacher.
Okay, you have them all in the book. I think that you are not writing now. Yes, can I continue?
Yes, teacher.
Okay.
Okay. Relative position of a line and a circle in the same plane. Here, look, we have the definition and the figure of it. A line which intersects a circle at exactly one point is called a tangent of the circle. Look, there is a line, L, and there is a circle here. And L intersects the circle only in one point, this point. And this line is tangent to the circle, okay? It's called tangent. And the intersection point is called the point of tangency. And this H is the point of tangency. So if there is a circle and if there is a line, let me show you here. I have a circle. Can you see this?
Yes.
And I have a line, this one. And when they intersect only, if you can see, only in one point.
Yeah, tangential, like
Yeah.
okay.
So this line, the pencil, is called tangent. And that point that intersects the circle is the point of tangency. Okay?
Okay.
And the other one, a line which intersects a circle at two different points, is called a secant. So as you see, there is a line and it seems like it cuts the circle so in 2 points. Look. So this is called secant. Okay, this is tangent, this is secant. Okay. Genti, we will have lesson with you 3rd hour, okay? Now, if we understood what is tangent, if we understood what is secant, I will continue. As I have said before, I am not asking definitions in any exam, but you need to know what is tangent and you need to know what is secant. Not like exactly the definition, but you need to know in a figure what is secant, what is tangent, okay?
Teacher, this will be an exam?
Circles? Yes.
Yes, sir. Oh.
We'll see how much we can continue. Then at the end, we will arrange together, okay? But you need to...
Okay, because it's this Friday.
This Friday is our exam?
Yes.
Okay. We'll talk on Wednesday. Now here we have chords, the properties of chords. So AB is the chord in the circle, as you can see. AB is the chord. A radius that is perpendicular to a chord bisects the chord. If the radius is perpendicular, we know now what does mean perpendicular?
90 degrees.
Yes, 90 degrees. If the radius is perpendicular to the chord, it bisects the chord. So it means that, as you see here in the figure, AH will be equal to HB. AH is congruent to HB if the radius is perpendicular to the chord. So here there is an example, if you can see. Now you can write these examples if you want, or they are again from the book solved. But listen carefully. Here, the figure is given. We have drawn the figure, but normally in the question, the figure is not given. You need to draw by yourself. A chord of length 8 centimeter is 12 centimeter away from the center of the circle. A chord of length, the length of the chord is 10 centimeters and it is 12 centimeter away from the center of a circle. Find the length of the radius. So here the figure is given. As I said, normally the question, this question is not giving the figure. We have drawn here. Okay, so you have to draw by yourself this figure. And we are drawing the circle, we are drawing the chord, and it says that it is 12 centimeters away from the center. So as you see, if we'll draw it perpendicular to find exactly the distance from the center to the chord, it's 12, it's given. And because this is perpendicular, we'll bisect the chord into equal parts. 5 here, 5 here, because it is 10 totally. Then we need to find the radius. So if we'll draw a line from center to the end of the chord here, this one is the radius at the same time, yes?
Then we should use a Pythagorean theorem.
Yes, only we'll use the Pythagorean theorem, and it will be x squared is equal to 12 squared plus 5 squared. Yes?
Teacher, can I go just for 2 minutes?
Okay, okay. X squared is equal to 12 squared is 144 plus 25. So x squared will be 169. Then x will be 13. Okay, guys, I hope that you are not sleeping, the others.
No, we're not sleeping, teacher.
No. Okay, it's okay. Did you understand? Is there any problem?
Yes.
Yes,
No,
teacher.
it's not a problem.
There is no problem. You understood? Okay. So which kind of elements we had till now? Chords. Then
Radius, we had
radius we had,
Tangent.
tangent line we had, One more line.
The one in the middle, teacher, I forgot the name now.
Second.
Second we had. And do we have anything else? Radius, diameter, chord, second.
We have the intersection thing.
Tangent, yes, okay. And now let's continue to see some more questions about chords. There is another property here. In this property, it says in the same circle or in congruent circles, if two chords have different lengths, then the longer chord is nearer to the center of the circle. The longer chord is nearer to the center of the circle. And there is one more property, but it's not, let me check if it is given in the next one. No, there is one more property, but it's not given here. It's forgotten. In the same circle, I can write here another property. In the same circle or in congruent circles, as you have here, two chords which are equidistant. We know what does mean equidistant?
No, teacher.
Equidistant, which have the same distance. Equidistance, equal distance, it's like equidistant, okay? From the center, are congruent. If the chords are equidistant from the center, it means that they have the same length. They are congruent to each other, okay? Also, this property is important. So if O, like here it's in this figure, if OE is say equal to OF, it means that AB is equal to CD, okay?
It's okay.
Okay, teacher.
Here we have an example, and in this example, in the figure is given that AB is 8 centimeter, AB is 8 centimeter, CN is 4, and OM is 3. And find OC, the radius. Now,
Teacher, can I ask
yes.
one question?
Yes.
They don't look congruent. They don't look congruent. I mean,
Which ones?
the E and F. How they
Here
can
it's
be?
not. No, here it's not. This figure is for this property, but only
Okay.
what we mean about this property. This figure
Okay.
for this one. Okay, they're not.
Okay.
Now here in this example, one more time, the givens. Check the givens one more time, and now I will write here in this part. So AB is 8, and look, OM is perpendicular to AB. So it means that OM bisects the AB. So AM and MB, they are equal to each other, according to the property. If AB is 8, it means that AM is 4 and MB is 4, yes?
Yes.
See, CN is 4. It means that also ON is perpendicular to CN. It means that ND is 4 also. So from here, we can see that AB is equal to CD. Yes? AB is equal to CD. If the chords have the same length. So what we said in this property, in this property, we are saying that if they are equidistant, they have the same length. So if they have the same length, they are equidistant from the center. So it means that OM is equal to ON because the chords are equal to each other. So if OM is 3, ON will be 3 also. Okay? Because they are.
But teacher, they don't look the same. A, B, and
Okay,
C.
okay, don't look to the figure. Look to the givens and the properties. Maybe it
Okay.
doesn't seem like they are equal, but the givens and the properties gives us that they are equal, okay?
Okay. Teacher.
Because AB is equal to CD, we will say that OM is equal to ON from the property. Now, can I find the X?
No, it's Pythagorean.
Easy. Now, X squared will be equal to 3 squared
Square plus 4 square.
squared. And this one is 9 plus
9 plus 16, 25.
which is
So X is 5.
25. So X is
5.
equal to 5.
Radius is 5.
Radius is 5. It's okay?
It's okay.
Yes, teacher, it's okay.
Okay. Are you writing or I can continue?
No, I took screenshots.
Okay. The others, can I continue?
I will watch the
Teacher,
video.
will you upload the videos?
Yes, yes, I'm recording now. I hope that I will upload. Here we have some more examples. Let's see them one by one. First one, in the figure, the radius of the circle is 10 centimeters and AB and CD, they are 16 centimeters. Find OE. Alexander, how will find this one?
Which one, teacher?
First one. First example. The radius is 10. It's given that the radius is 10. A, B, C, D, the chords A, B, C, D, they are 16. It means that they are equal to each other. And we need to find OE.
So the diameter is 20.
Diameter is 20, but it will help to us to find the diameter. I mean, in the solution. Can you tell me to draw a radius from a point to another point? Because we have lots of points here. For example,
Teacher, AF is 16 over 2. So
okay,
E will be 8.
okay, AF will be 8.
From O till C is the radius.
From O till C is the radius. Okay, R I'm writing, or let me write because my R doesn't seem well.
CE will be also 8.
CE will be 8, but radius is given. Why I'm writing X? Alexander, why you're not telling me? What is radius?
10.
10. And what we are looking for now? OE. OE we are looking.
And with Pythagorean theorem,
With Pythagorean theorem, which will be,
it will be
6.
10 square
yes,
plus 8 square is equal to x square.
minus 8 square is equal to x square. So it is 100 minus 64
Minus 64.
x square. This is 36 is equal to x square. Then x is equal to,
6.
Root of 36, it will be 6.
yes, yes. Okay, thank you very much. One more thing, why I'm asking the others, why Alexander decided that CE is half of the chord? I mean, it's 16 over 2. From where?
Because they are congruent, CE and ET.
Why they are congruent?
They are perpendicular
Because
to each other.
because here it's not given anything about that they are CE is equal to ED, but we accepted that it is like that. Why? Because OE is perpendicular
Yeah.
to CD and OF is perpendicular to AB. Because of that, directly we said that AF is half of it, or CE is half of it. Okay. Alexander, choose to draw the radius from O to C. If you would draw the radius from O to B, how you will do?
It will be the same.
It will be the same.
The same teacher.
For OE, X, but also OF is same because the chords are equal. So OE is equal to OF also, equidistant. So you will find the same thing again. It will be the same. Okay, in the second one, what is given? AB is equal to CD. Again, the chords are equal to each other. OM is perpendicular. You know, this sign is that it is perpendicular to AB. And ON is perpendicular to CD. Okay, ON is equal to OM and it is 4 centimeters. I'm writing for you. AB is equal to 5x plus 1. And CD is equal to 4x plus 2. Find the radius of the circle. What do you think? What we'll do here?
4x plus 2 over 2. Teacher Pythagorean Theorem.
CD, look here, if this one is OM is 4 and ON is 4, we know this one. And I'm going to draw the radius from O to D. And CD is 4x plus 2. The half of it, what will be?
2x plus 1.
2x plus 1.
2x plus 1. Here we have 2x plus 1. Here in the second one, and in the other part, again, I will draw the radius from O to A or from O to B, doesn't matter which one you want. And here, let's say this is R, and this one will be R. And BM, if I'm looking for BM, what will be BM?
2.5x
2.5x
plus
plus
0.5.
0.5.
I will write like this, 5x plus 1 over
Yes.
the Pythagorean theorem for both of them. What will be? R squared is equal to 4 squared plus 2x plus 1 squared. Yes?
Yeah.
And for the other one, I have R squared is equal to 4 squared plus 5x plus 1 over 2 squared.
But teacher, they won't be the same.
Oh, they won't be the same.
If we calculate.
What do you mean they won't be the same? Which one?
Teacher, 4 square is the same for both, but 2x plus 1 and 5x plus 1 over 2, it's not.
Okay, we'll find, if it will be both of them the same, we cannot find anything. We'll cancel everything. Yeah?
Teacher, first we can we can find the x, like 5x plus 1 is equal to 4x plus 2. It will be easier, I think.
Okay. So, yeah, also like that. Yes, because they are
We have only for radius unknown.
because they are equidistant, it means that AB, and it's given that AB is equal to CD, yes. From there, we can
Okay, now okay.
plus 1 is equal to 4x plus 2. From here, when you will solve this one, x is equal to 1. Okay, now I couldn't talk. In which one you want, you can write the x and you will find the r. R squared is equal to 4 squared plus 2 times 1 plus 1. It will be 3 squared, which is 16 plus 9 is equal to 25. Then r is equal to 5. Okay? Yes. It's better to do firstly like this. I would do like very hard, long way, as always. It's okay, guys.
Yes, teacher, it's okay.
It's okay.
I think
Teacher,
that
now we will have art or mathematics.
one more
The
time.
second hour. We will have art or mathematics again. Math. No.
Mathematics will have. I mean, now normally what you have in the second hour? You will,
Art.
We
I
have
have
you will continue normally. Then we'll have in normal hours like fourth and fifth one. We have. We'll
yes.
have again. Today we'll have 3 lessons math. I mean.
And next week, teacher, we will have
First lesson is